Nice. Somehow OBS decided to stop the recording. Great. I was down here talking about the algorithm of Bresenham, and yeah, where is it? There we go. So that's what I wrote down. Okay, I was just talking about the variables and the code here, and I have to do it again, sadly, because I didn't record that. And then I talked a lot more and did a lot more stuff, and it's all lost. Okay, nothing to cry about, let's just continue. Right at this point, I wanna get this video series done. It's gonna be, in the worst case, 10 parts, I don't mind, it's gotta be done at some point. Okay, back to this. I don't know where exactly I stopped with this, and I don't want to watch it again. So I will just briefly explain what I did here again. And that was basically, I was checking how many registers we need, and I came up with the conclusion that it's 6. That is because we start at some point x0 and loop to x1 at that point. So we always need x and x1, because x will be x0, so we first start with x0 in there, and we're gonna use that as x from that point on. That is simply because at that point we just have an equation which says that x gonna be x0, and then we start the loop. This basically means that we can just store x1 once and then x, and then we also have x1, which is the target. We also store that all the time because we have to check it all after each loop if we have to loop again, or if we stop at that point. So it's the current x and the last x. That's where we loop, and what we use them for is, at this point we generate the difference of x points, and that is simply done by simple subtraction at that point. So basically, yeah, that's stored, and later on, which is at this point after we did this operation, dx will only be used with multiplication of 2, so we can just go and multiply that by 2 and use that from that point on. So that's when we have that's why we have like 3 variables. We also need a current y, which is y0 at first, and later on we can just use that as y again, because it's the same value, and we don't need y0 anymore, so we can just declare that as y and continue to change y. So that is the current y. With the other y given, the y1, which we can store in some register any, we're gonna override it instantly with the difference of it, which is here. We just store y1, and then we instantly just do this subtraction and discard this one because we just don't need it anymore. So we store dy, and dy will always be used with multiple of 2, so we can also just directly multiply it. There's like no need to store dy any longer. So that's 5 registers at this point. We need one more, and that is the magic d value. I just called it magic because like it's magic. It's doing things which nobody of us want to imagine right now or understand in detail. So basically, this is a simple subtraction which will lead to this d. This is already handled. This is handled. So then we just loop over the axis and plot every point. And if the d is greater 0, so that is nothing we have to store. We're gonna increment epsilon by 1, and we can do that in several ways. There is the possibility or the way to store the 1 as a constant in a register, but we don't need to do that with the current CPU design we chose. We can, for example, add an increment instruction that is fairly simple, and actually almost it's a present. It's like cheap. Or we can just add and put b equal 1 using the increment, the immediate input. So there's actually 3 ways of doing it, and it's like super easy to choose one. And here's a simple subtraction with the value which we already have stored, to just override d, and we do the same here with the subtraction instead and dy. So that's all simple operations. That's addition, that's subtraction, that's multiplication by 2, which is just an addition, incrementation, and yeah, that's actually all the instructions we have. The most complex one would actually be the greater than in this, and of course the plot, because we don't have plot yet. But damn it, I already said that this here is gonna be some 4 bits in the instruction set for direct hardware access, so that's no big deal. Like when we increment x at this point, we're gonna set x in the display already, and when we have the y at like here at this point, we're gonna just write y to the display either here or in the else part if there's something like that. So that takes a bit of design choice, but we're gonna it's easy to do that, I assume, when we got to the point. Yes, so yeah, that's actually just the stuff which we have. This was the code, and it just does magic stuff, whatever. So, considering that, I continued building. I said, this has everything. This has more than we even need. We just need addition, subtraction. That's like literally everything we need. Yeah, that's actually everything we need. And now this has all the logic stuff. Like we don't even need, we need this for subtraction, but only one of them. Still, that's a lot, like barely anything. Yeah, so at that point I decided we don't need to shift down, because we're not doing division anyway. We're just not doing division, and we're not shifting down. So that's why we don't need it, and that's why I immediately write this up again to the register input, register file, save lines. Because of a bug, I had like these here not set, causing the signal to be on. It was quite handy to actually place the repeaters, but then I saw the bug and fixed it. Yeah, what else did I do? I placed down these kind of these decoders. I actually intended to use this decoder, but then I noticed, this one is 2 wide and the inputs here are 3 wide. So yeah, I built these from scratch, and I also placed down this one here on top. Normally you have at least 1 redstone torch in here, so something like this. So this torch will be off, so whenever this torch goes on, it's gonna save whatever value is on top. So there is a need to decide when to save, and that is why you connect the clock line to this. I'm gonna show you in the simple 5-hour CPU I made. Yeah, I'm just sorry that it aborted the recording. I don't know why it aborted the recording. It kind of pisses me off. But yeah, it happened. But well, you didn't miss much except my talking and me building the decoders. Great. Yeah, thing is, I want to do something similar to this. I mean, like, this is the same CPU structure in form of design, and I just want to put the instruction set right here, like in the other one. And so it's gonna be that this one will be connected to this, and the one here gonna be to there, and the middle one go up and feed the decoder on top. As you can see, here's the clock line, which actually enables when to write, and that if that happens, it's gonna send a pulse of 2 ticks to write. That's all it takes. So yeah, that's everything which is gonna happen here with the register stuff. Once that is set, we're gonna add some immediate line, because that is very needed. if we want to set the x0, x1, like these given points here, we're gonna insert them using these immediate lines here, but I'm gonna make them 4-bit and not 8-bit. We have an 8-bit CPU, but it's okay to use 4-bit immediate because we don't need more. And if we're gonna implement something like a multiplication, you normally don't want to go over 255 because then you got an overflow, so 15 by 15 is the maximum you can do anyway. So that's also using this part. We're also gonna have 9 bits for the register addressing, and this also gonna look pretty much similar, that we just put all the ALU flags directly connected to the ALU, because I'm too lazy to build a decoder for this, or encoder, whatever. There's no shift down, so this is not needed, and this is kind of the branch unit. So we're gonna go back to that later on after we finished all this part, all these sides, because that's the simple side. It's like really straightforward, just connecting wires. It's really, wow, tension, 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 a lot of tension. Yeah, what I stop. First redstone video ever on my channel, actually. At least first proper one. Well, proper in terms of I'm derping here and I'm getting tired, so I'm a bit of stressed. No, not really stressed, but you know, not in the best condition. Yeah, anyway, I need some color for these two, and I'm just gonna use red and green, because I always use these colors for. Oh no, I need more space. Red and green, like for me, the perfect colors to actually address the two register A and B's. And this time I'm gonna use blue for the safe. So that's, oh, I still have that enabled. That's not good. So yeah, I was using all this stuff here with this nice, awesome tool. I was just able to put that stuff like this. Still not public to users of this server. I'm sorry. If you want that, go back whoosh. Yeah. Oh, and bug me if you want this feature. Oh wait, the feature of automated redstone placing, like so. It only works for this block and not that. Like these two combined don't work. So like this, and we can actually put it here and it will still put it there. So it's real nice tools, both of them. Can only recommend to kick the asses of your admins for them to actually implement that stuff to public. Don't, I'm lazy. So yeah, all it takes is now to wire this stuff up. So let this one be red, green, blue. Red, green, blue. Oh damn. Okay, it doesn't match. So I'm gonna use green. Oh, tired. Okay. This has to go something like this. No. Something like this. Yes. Okay, this works. So I'm just gonna put it like this. On. Just saying I have awesome tool while I'm not using it. Don't need this. No. Just put, well, am I actually checking if it's not redstone? I bet I'm not. Oh, stupid. I should fix this plugin. Oh, it's not a plugin, but I should fix it anyway. Why is it doing that? Oh, I know why. Annoying. So yeah, that's actually how this works. So just can put like something like this. Doesn't really matter. It's probably better if I like go this. Okay, there we go. So that will be the connection of this here. It's kind of funny, you can always see who made something. If I put like if it's my stuff, then it's like orange with the white border, and if it's Woosh stuff, it always contains Woosh and it has like this turquoise color with a golden border. So, and green text, and I'm always gray text. So it's kind of easy to see who made something. Okay, this one's red. Why do I have Lego Racer music in my head now? So that will be like so, and so this one is here. There we go. So boom, this one goes here, and this one here. So like this. Please let this work. Yeah, right. This is actually catastrophic. So this works. Ba-bum. Let's do the same again. So like this. I'm gonna put it here, 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 and here. Not that one. Go away. There we go. So it's just needed to put the blue one on there, and actually I got a lot of space here, which I really dislike, because that makes it all quite ugly. I could move all these over and like insert the immediate in a kind of disgusting way from below here. That would actually not the baddest. It will actually be a good idea. But I will like let this here decide, because this one always has to go diagonal down here, and so it kind of ends up at random places, and thus have to put it somewhere somehow. Anyway, I made this one be the one and this one be the one, so this one has to go on this side, and the one back has to go on the side here. Oh my throat is like dying slowly. Is it still recording? Yes, it is. Don't you dare to stop recording, stupid OBS. Okay, OBS is actually working the best of all weird softwares which are out there for recording. Yeah, but yeah. Okay, random stuff on Discord. Weird, I don't get it. Well, I'm alone. Where did they all leave to? What's wrong with them? Derp. Horrible. But alone, quiet. Peace. Inside the flat, not outside. So this is the point where it's kind of critical. My brain is going backwards at this hour, like it's really slow. Just put this, okay, this is like not advantage to have this feature right now, because I just need to put like this here. That's the problem with this. It's like super annoying to wire it up. Oh, great job. Boom. This can actually be here, and this can actually be here, and this can actually, it's actually I don't approve. This is not gonna be a static wiring. And if it's not a static wiring, it's wasted effort. Yeah. That's the point of this stuff. Doesn't work quite right. Yeah, so I only have the last one left. And this one can actually go like this. And pass the others sidewards to then go down over here. And as you can see, it's possible to move that stuff over quite a bit, because we want to have it compact and not disgusting. But this is actually supposed to be in the middle of the other two, not at the side. So let's let this one go down a bit more strict. Nope. Not aesthetic. It's gotta be aesthetic at least. If it's everything, if it sucks, whatever, it has to be aesthetic. That's important. So like this. Look at this. It perfectly fits here. Perfect. That's how it has to be. Probably gonna be a little bit problematic if I want to send a signal up all the way, but that's a different issue. Let's just ignore it for now. The bigger problem is that I somehow have to send a signal up here, which is gonna end up here. So I would probably have it set words like here, which is really not so nice. Maybe I should like do it this way anyway. Just to be able to put like this one here, because that's much more nice. Something like this. Yeah, I approve. It's not pretty, but it's totally fine. For this build. They're captured in it. I need to repeat in front of this anyway at some point. That's kind of sad wiring. What's with that? Okay, so that one is done. There we go. So this should look much better. And it's close enough, so I can just put all these wires here. Oh god, gotta get rid of this. No, I'm not gonna do this without my tool. Okay, so then more wires, all mess. Damn it. Okay. There we go. So I just need immediate, some kind of color, and a wool block. Oh, I'm gonna use brown. No, brown is just disgusting, so I'll use this one. I said 4-bit because we got a 16 by 16 display, so we need 4-bit. 1, 2, 4. Oh, OMG. By the way, where's the LSB? On this side. Okay, good. So I'm just gonna put this down and then go all the way over here and yeah, that's basically it. Oops. Okay, put this like so, and put this like so on that one the same way. That's the first 4 bits of this CPU. It's a bit sad that it's the deepest point, which I have to scratch now, and you know, it's just not aesthetic. And it's also sad that I have, and this has to be directly on the torch. It's annoying. Just gonna put this like so, and now I can just put repeaters in here if I find them in this messy stupid menu, like so, because then it's on the right lane. So yeah, that's immediate. There we got register B, and that's register A, and that's register right or C. Which somehow will receive a patch to be disabled when it should not be saved. And I fear I have to put that on this side. Well, okay. Or just need some block. Okay, that's our timer color. Now I just use that. That's too similar. Okay, but no. Stupid color, stupid color. Stupid color. That's okay. But it's not okay. Well, okay, I take this. It's not black, that's brown. I just have to put like so, and that disables it all. Yeah, something like this. I need a redstone resource pack again. So like so, like so, like so, like so, like this, like that, like banana. Yep, okay, good. So that's disabled for now. Yeah, okay, so how to do so, how to make a video about so, and actually, that's the 2 most important words in human history, human society, human banana republic. It's in the way. Oh, why is it in the way? I don't approve. I dislike. What to do about this? I know. So, okay, easy fix. Now we just have to put this like so, and cover this up, and do the same for the neighbor. Also, this is just the ALU control flags. Real easy going. Here we got the same or similar issue, and we're gonna solve it the same way. I'm just gonna put these to the side, then this issue is no more. Okay, there we go. There we go. 2 flags done. Next one. Oh, flags, control bits. No, that's no good. Okay, that's like this. Oopsie doopsie. Oh. That's good that we get still this much of a padding here because, well, it's easy to align the wires properly then. Oh, I should enable the tool again. But nah. Totally good shape. Maybe I should just do this tomorrow morning. Maybe the microphone feels better then and just don't do the derping anymore. Oh well, I just use blue here because of reasons. It's even the last control bit, so good for recognizing. Like, will be pain to actually keep these here apart. I can at least give this one a nice color. It's the most unused one. It's just used for subtraction and that's it. Awesome. Okay, so there we go. This is the whole core of simple CPU, which is too stupid to branch. So we're gonna make it branch, and that works by having stuff like carry out. Okay, no, I'm not gonna record anymore. I'm gonna go to bed. This is carry out, and carry out's gonna go over here, and then we're gonna make a 0. So we got 2 flags and stuff. Oh, I'm gonna do that tomorrow. No, not now. 40 past midnight. I got 1 misrecording, but yeah. Well, that's the target, the whatever I did today. So, 4 to, let's say it's 4 hours of work, considering that I was slacking off in between, making breaks. So 4 hours of work is like this kind of mini CPU base without additional stuff like flags and branching, and instruction set gonna be here, so, or the ROM gonna be here, and this display and that display gonna be attached to somewhere the output of this, and some bits here in the what's it called, ROM instruction set. So this display gonna be positioned to here relative to this one, so that means I'll have to rotate this one by about 180 degrees tomorrow. Nobody's online anyway, so good night for me.